Assalamualaikum and good evening. I assume evening to Mr. Dr. Zaid. Alright, so today I will be presenting a network optimization study for a high density residency environment. So the subject of this case study is a standard based on my house. It's 20 times 75 square feet foot terrace house. On paper, this home has a powerful connection, Maxis Wi-Fi 6 plan with I think about 800 megabits bandwidth. However, the raw speed is not the same as actual performance. So the network is currently anchored by a single ISP gateway, so which is like the primary X point for the entire house. It has managed a very heavy load, 20 active clients simultaneously. This includes critical security cameras, workstation, 4K smart TVs, and a cluster, I think roughly about 40 mobile devices. As my analysis, this is single node setup is struggling to keep up. This is the introduction that I have told about from the earlier. Okay, next slide is the problem statement. Okay, so despite having 800 megabits deficit, the user experience is poor. We identify two major bottlenecks, that is physics and congestions. So the first of all is the spatial coverage deficit because the property is long and narrow. 75 feet signals degraded significantly as they pass through concrete walls. This creates a critical dead zone in the backyard, causing the rear security camera to fail frequently. So the second one is the concurrency bottlenecks. At night, when all 20 bus are active, the router processor gets saturated. We see high latency and packet loss during gaming, not because we lack speed, but because the router lacks the airtime or fairness to handle that many users at once. So next is the project objective. So to solve this, I have four clear points of my objective. For the first one is to analyze the specific failure points in the current layout. So the second one is eliminate the wireless dead zone to ensure 100% security uptime. So the number three is to optimize the traffic flow to reduce gaming lag. And the last for the objective is to propose a hardware solutions that actually utilize the full 100 megabits that we are paying for. Okay, next is the hierarchical network designs. So the core of my solution is a shift in architecture. We are moving away from a flat single router topology to hierarchical collapse core designs. In simple terms, we are splitting the network into two jobs. So the first one is the core layer, our Maxis gateway. So it will focus purely on high-speed routing and internet access. And then the next is the access layer, comprising a new switches or and access points will handle the device connectivity. By separating this function, I ensure that the heavy local traffic doesn't bog down the main internet router. Alright, so the next one is the network layout and floor plans. So as we can see here, my 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 house like this. So when during the high time, we can see the router is working too hard, working too hard for the internet capacity. Alright. So the next one is the cabling details. This is the basic thing that I found in my house. So obviously we have Cat6 for our connection connectivity through modem and router. And then the fiber optic is supply the internet from the outside into the house. And then of course we got the Wi-Fi router. So I think right now we are using Wi-Fi 6. Wi-Fi 6 router. So it's still new, but the market also have the Wi-Fi 7, so it's really advanced. So far at my home still using the Wi-Fi 6 router. So the next one is the suggestion for network upgrade, or I call about proposed solution. So to implement this design, I'm proposing a hybrid wired or wireless solution built on three pillars. So the first one is the traffic offloading. I will install a gigabyte Ethernet switch in the living hall by hardwiring the heavy device, the PC and smart TV. We will remove about 40% of the traffic from the Wi-Fi. This immediately clear up the airwave of the floating phone. So the second one is the coverage extension. I will deploy a second Wi-Fi 6 access point, or I call like Wi-Fi extender, into the dining area. Crucially, this connect back to the router via cable, not wireless. This passes the signal right through the back of the house, fixing the dead zone for the yard camera. Uh, for the this one, I prefer use cable because it's more direct power and more direct internet from the router. So if it can use wireless, but I think it's not strong enough using better than using the wired. So the third one is the backbone. So everything link up using the Cat6 cabling. This ensure a full duplex stable connection that guarantee the at 100 megabytes speed reach every room front to back from A to Z. Okay, and then for the last one is the conclusion. So in this conclusion, this study proved that for a home with 20 devices, simply buying a faster internet plan is not the answer, but the bottleneck is the infrastructure. So by upgrading to this hierarchical design, we achieve three things. So the first one is the 100% coverage for security. Second one is zero lag for gaming, thanks to the traffic offloading. And then the third one is full value. Finally, utilize the 800 megabytes subscription we pay for. So this transform from a congested consumer setup into a scalable enterprise grade environment. So that's all from my side. Thank you.